So here we have the folder directory. This is where your video file will be and your vibration file will be. It also contains where your media pipe path, where your model, your post landmark light model would be. Your camera calibration directory is right here also. That would be this file right here. Camera calibration right there. Okay. And then we also have YOLO right here. I should add another line to make YOLO, but it should be able to run as long as you have it in the base directory right here. And the first thing we're gonna do is talk about the researcher class. So the researcher class loads from the researcher settings. That's this right here. So you just punch in your researcher name, and then it creates a researcher class. The researcher class has the settings that imports from this file right here. It also has your video and your video data. It doesn't have the vibration file yet because I haven't implemented it. But here's the load video. So if there is no video, it is loaded on demand. So it doesn't always load. It only loads when you need it. And once it's loaded, you don't have to reload it again. So it checks to see if the video is there. And if it's already there, it exits. Otherwise, it takes the video path from right here. Okay. And then it's going to load it. And then it's going to, if it either throws out an error, meaning you did not load it, or it actually loads the video. And then it will get from the video the frames per second, width, height, total frames, and the video path. That is actually redundant. And then it prints out the path, and then returns the video. Oh, so I guess it's not redundant. Next, we have the run camera calibration file. So here you just change this to whoever you are. And then it loads this, and then it loads the camera calibration. So all these files are in the library, okay? And then here you select the script you want to run. So this is a whole bunch of booleans. So you want to select either run calibration, distortion removal, perspective transform, okay? And how you do it is you just take pictures using the camera settings. So the camera settings are right here. You get it from like the camera itself when you're in the research lab, okay? And then what it does is it saves it to the camera file so that in the future you can just pull up what the camera settings are. You don't have to ask who it belongs to. I guess you can leave it blank, but that's not really good practice. So you have this dictionary and it gets passed into the calibrate file. So you create a camera calibrator file, okay? And is actually this right here. So here's the class, the camera calibrator. It initializes the researcher and all the settings and all the paths, all right? And here's the calibration file. If you don't have one, then you can actually make one. Otherwise, it will load it so you don't have to rerun the calibration every time. And here is all the parameters, the global settings. This would be global settings, or the settings of the calibration, all right? And then this is also the line edge, and that's this right here, okay? So either it has it or it doesn't. Either way, it's gonna run. If it doesn't have it, then it's gonna complain. It's gonna throw an error for you, or was I? Okay, so, okay, yeah. Let's move this right here. Okay, and then this is to calibrate. Um, so I think I grabbed this from the tutorial. Yeah, I think I grabbed it from the tutorial, and it should be correct. And then it's gonna print out the results, so you know when you run the calibration, it works. And then it's gonna save the results for the calibration into this file right here. All right. Where is it? Right here, the calibrate.npz. Okay. And it's going to save it to this directory wherever you had it, the settings is. So pretty much you want to copy, paste it, and then change all these directories to whatever is relevant for your computer. All right. And then here is the load calibration. All right. So once you've calibrated it, you don't have to calibrate it again. It's just going to load the calibration as needed. This is the pixels to meter. Okay. So what is important is the perspective transform. So out of the box, it doesn't use perspective transform. So it loads this by default. So you can see this is not right. All right. Okay. But the perspective transform, that right here for this file is actually working. So what it does is here you have your real world X and Y meters. All right. And then XY meters is going to be converted, can be mapped to, is a bijective mapping from UV pixels to XY meters. Okay, and how you get that is you take this and then uh, 0x is this wall right here. 0y is right underneath the camera. So this is the 4 meter line. Um, I'm not sure what line that is. So this is 4 meter line, 5 meter line, 6 meter line, and it's on the bottom edge of the tape. Okay, and then so what we did was we just looked at the file name. So you have the 0x, all right. So you see it's pushed up against the wall, and you have the 800 centimeters wide. So this is the 4, 5, 6, 7, 8 meter, all right. And we're just mapping this bijectively from pixels to the meters in the real world. So the way you get this is you open it in Paint, right? And then you can look at this cursor down here, and then that's how you get this. You get this number right here, and then you just copy it into the Excel file, all right? And then you do it as many times as you feel like you need to. More data means more accuracy, so that's good. You want to do that tedious work. Yeah. Where was I? Okay. All right, so that's the pixels to meters. So perspective transform um, is from the Excel sheet. All right, the undistorted. Okay, that didn't. I don't think I made that correctly, so we're not using that. This is to calculate perspective transform. All right, so it loads the Excel file. All right, so you can see the perspective transform Excel file, and then it does the mapping. There's a tutorial Dr. Her sent me that I mapped it off of. All right, and it loads it also loads the calibration, right? So it loads the calibration file, and then it calculates the perspective transform, and then it resaves it. All right, so it loads the perspective transform into the dictionary, and then it saves it into the calibration file. All right, so we don't have to do it again. This is the remove distortion. I don't remember if this is working or not. Oh, this is, yes. So the remove distortion takes the entire video that looks like this and converts it all the way to this. All right. So when you run distortion removal, you pick a start time in seconds and then the end time in seconds, and it saves it to whatever is in your settings. And this is the calculate perspective transform. So you change these based on what you want to run. Okay. All right. Remove distortion, undistort folder. Okay. So when I was running tests, I actually made another researcher called Ghost Settings. All right. So this is, yeah, you can see this has the undistorted calibration directory. I was working on that. I don't think this is actually being used. And then this is a draw meter grid. So this right here actually loads the draw meter grid, and it draws the 1 meter grid, and we kind of just use it to like eyeball to see if the calibration is working correctly or not. Okay, and then this is for the undistorted version. It doesn't really work well. That's down here, so it's not working well. Draw meter undistorted. And then this is the X on the Y line. So I also did the edge detection method. So what it does is it detects the edge based off of this inside wall, all right? And we're like, this is the 0. I forgot what this is all the way over here actually represents. But it calculates the distance on the X because we were having problems with that. The Y is good. So you can see from right here, the Y is pretty good. So that's the 400, 500, 600, 700, and it looks pretty good. I think it passed most of the tests. All right. So these are the X on the. So these are just feet from the left wall. This is the pixels to meters. So what it does, it calculates the Y meters from the perspective transform, and X meters is computed from distance from the left wall in feet, and then it later converts it to meters. All right. Yeah. Um, Calculate perspective transform undistorted. Okay, that's I don't that was not working. Detect hallway edges from the video. So what it does this is that it loads the video. Okay, the video is loaded into the researcher. So researcher class handles uh, the video, uh, the settings, and where the models are coming from. Okay, the model directories and all that stuff. Uh, I didn't get a chance to get it to load the vibration stuff, but I'm not on the team anymore. Let's see. Okay, so it takes the first video, or takes the first frame of the video, and it does this calculation. It does this calculation. So here's the code. It does all this calculation, okay, and then it saves these two lines into the researcher class. Where is it? Right here. So it has the left edge and the right edge line. Okay, so I kind of lost where I was. Uh, we're not using that. Okay, detect hallway edges from the video. Okay, yeah, so it detects the edges from the hallway video. This is actually the same code. Get frame at time. So this is just a helper function to get the frame at 0 seconds. And that's why we use to detect the line edge. You could get a frame at some other time, but we don't really need to. Okay, so did I cover that? Covered that. All right, so run calibration. Okay, so calibrate. So this is in the library. No, this is the run camera calibration. So this is the run calibration file. Define calibration, remove distortion. Oh, this is just okay. So the Jupyter notebooks. This is where I did. This is kind of my sandbox where I just test my code. So yeah, so you can see this is from the tutorial. It finds the checkerboard and then it runs the calculations using whatever is under the hood. All right, and it prints out the camera matrix when you're done, and it runs remove distortion. So this runs the remove distortion for I don't remember. Okay, test calibration, edge detection. Okay, run RoboFlow. So run RoboFlow. You load the researcher. Okay, and then you run the RoboFlow, and you put in start time, end time, and then it outputs a video file. All right, so it has all of this stuff on it. Okay. Um, yeah, so it just runs the RoboFlow. It uses the YOLO model right here. It runs the video, and I think it. Do I have? Did I run one of those? I don't know. Okay. Okay.